This word problem is one that we're going to have to solve by making a graph or two graphs, graphing two different equations. But we also have to write our equations, and it says that in the directions. So let me read the entire problem. Just follow along. It says two groups of workers are painting a bridge in the bay. The first group is responsible for painting the north side of the bridge, and the second group is responsible for painting the south side of the bridge. The first group has already painted 1 kilometer of the bridge and is painting 3 additional kilometers per day. The second group has already painted 5 kilometers of the bridge and is painting an additional kilometer per day, 1 additional kilometer per day. When the two groups have painted the same amount of the bridge, how much of the bridge will they have painted? So, first I want to remind you all that we're definitely not going to use x and y as our variables. If you look on the bottom there, along the x, let me point that out. What I'm talking about is right here. Along here, even though there's a little x right there, we're going to use days as our variable, and probably we want to use the letter D for days. Likewise, if we look at this axis, although it says y, we're not going to use the letter y. Since distance is what's represented on this axis, we'll probably use the letter, well, we don't want to use d twice. For distance, let's use k for kilometers. Okay. All right, how many kilometers? You don't want to use the same letter twice. So let me make a note of that here. Let's use d to represent the number of days. I think I can make that smaller if I can move it over here. Let's use d to represent the number of days. Also, let's use k to represent the number of kilometers of kilometers. Okay, the number of kilometers. All right, again, don't use the same letter twice. D and K, two different letters, we can do that. All right, so let me move that note up here and we'll remember what those stand for. And we're gonna, I'm gonna use colors here. For the first group, let's use blue like they did to write an equation. Remember, I'm gonna highlight that. Remember, we have to write a system of equations and then graph them. In other words, we have to write two equations. And again, I'm going to say one will be blue and it will represent the first group. Okay. The first group will be blue. Okay, so the equation for that will be the number of kilometers that they have built or have painted, sorry. The number of kilometers, we'll call it K, will be let's read it again. How many, the first group, they painted 1 and they do 3 every day. So the number of kilometers will be the 1 that they already have. I'm going to put the 1 here, plus 3 every day, so 3D. The number of kilometers that that first group paints will be 1 kilometer plus 3 every day. Let's use yellow for the second group. Second group. The number of kilometers that they paint, let's see, how many let's go back up here and highlight the second group. They already had 5 done, and they do 1 every day. So their equation will be the 5 that they've already done added to 1 every day. And there we go. So now we have 2 equations, and we can graph them. Now, that first one, let's go back to blue and graph that first one. The slope is 3, but we want to write it as a fraction. We want to do 2 things. We want to write it as a fraction and then write that fraction in a way that we can use on this graph. So the slope for the blue, for the first group, is 3. I know it says 3 there, but we want to write it as 3 over 1. And now we want to find out different ways to write 3 over 1 that we can use on this graph. Because, let's see, I guess we can use 3 over 1 because we can go up by 3 and over 1, can't we? Yeah, on this graph we can. On some graphs we can't. So 3 over 1 is fine. Let me erase that little equals. Our slope is 3, and our intercept is positive 1. Let me show you what I'm talking about. There's our intercept. And there's our slope, but we wrote it as a fraction. So we want to start by putting a point or a dot. And I think I want to make that a big dot here. At positive 1, which is right here on the y-axis. Then we want to go up 3 and over 1. So let me make a little hash mark for just a second. Up 1, up 2, up 3, and over 1. So that's where we're going to make that point or dot. In fact, I'm going to do more than one of them here. Up 3 and over 1 would be here. If I went up 3 and over 1 again, I could just keep doing that until I run out of room. And you could probably see now that these, 4 dots, 4 points, they lie in a straight line. We're pretty accurate with our graph. So let's go ahead and connect those with a yellow. Oh, wait a minute. I'm sorry. Those should be blue. Those dots should be blue. Let me go back and make them the right color. Sorry. I don't know why I said yellow. So those dots start at 1, go up 3 and over 1, up 3 and over 1, up 3 and over 1. Okay, good. And let's connect them with a blue line, not a yellow line. All right. This is the part where it takes kind of a steady hand, which is what my problem is. Okay, good. So that'll be the graph. It's too thick, though. That'll be the graph for our... Yeah, it's not perfect, but you get the idea. Okay, yeah, let me fix that just a little bit. I want this to come out as precisely as we can, and it was off just a bit. So I just want to, while I'm doing this, just say that usually, or I should say before we had, the pandemic, we would do this in class with actual ruler on a piece of paper. And it's just a skill that obviously I'm not very good at, but it takes practice. It takes practice with this, because this is not the kind of ruler I'm used to using. So I'm having some difficulty here getting this to stay where I want it to be. Oh man, it's trickier than I thought it was. Bear with me, guys. We're gonna have to go with that. we'll see where it yeah, it's pretty darn close. All right, so now let's do the yellow one. So the slope for that one, with the second group, the slope is going to be 1 over 1. It's equals 1 over 1. And we're going to start at 5. Okay, we're going to start at 5, and we're going to go up 1 and over 1. Maybe I can do that a little bit faster this time. Here's my point. We're going to start at 5 and go up 1 and over 1. Up 1 and over 1. There's already a dot there. And I'll just keep doing this till I run out of room. And then you can see that these also come in a straight line, form a straight line. Do I want the right thickness here? There we go. Maybe I don't spend as much time lining this thing up here. Right about there. It's good enough. And here's our line. All right. And so we're going to notice that these two lines, they intersect right here at that point. That point has I'm going to say first it's an x coordinate and a y coordinate, but I'm not going to write x and y. Remember, instead of x, we're going to put d for days, and instead of y, we're going to put k for kilometers or distance. So that point, the d value would be 2, and the k value looks like it would be 7. All right. So we've written our system, which I highlighted in yellow. We graphed them. I didn't highlight them, but let me do it now. We graphed them, and then we can write our solution. We could answer the question. I didn't copy that little box, but if you read the question again, it says, how much of the bridge will they have painted? In other words, how many kilometers will they have painted? And let me just say it, and I think once I say it, you'll understand the answer. The question is, did they paint 2 or 7 kilometers? If you look at that red ordered pair that I have, those red numbers, the 7 is how far they've gone or how many kilometers they've gone, how many kilometers they have painted. So in the box, you'll put 7 or 7 kilometers. Okay, is how many kilometers they painted. But we had to graph this in order to get that answer. I should say, graphing is one way to get the answer. And you probably have seen already that we could have done this with substitution, and we're learning a new way today. Some of you already did it. Elimination is another way. So before I finish and wrap this up, I just want to say there's almost always more than one way to do the problem. Graphing is just one of them. Okay.